Hi there, folks. Today we're looking at surface areas of prisms and cylinders. And a prism is really just a special kind of polyhedron. So remember, a polyhedron, we take polygons, stick them all together to make a three-dimensional shape. But a prism is a special version of that where two of the sides are congruent and parallel. So we have two faces, so two polygons that make up the shape that are congruent and parallel to one another. All right. The bases are the parallel faces of this thing. So when we refer to the bases of the prism, we're talking about those two parallel congruent faces. All right. Then the lateral faces are the non-base faces of the prism. So the pieces that are connecting those bases. All right. Here's kind of what a prism will look like. If I look at something like this guy. This guy is a pentagonal prism. So it's a prism where the bases are pentagons, and then the lateral faces are all rectangles for this one. All right. And so the reason I know that the pentagon are the parallel congruent faces is because those are the only two shapes that are the same in this thing. Okay. And that's what makes these the bases of this guy. Even though we tend to think of the base as the bottom, for a prism, the base is just the two sides that are parallel, that are across from each other, that are the same. Okay? And so those are the two sides that are the same in this one. So this is a pentagonal prism, and we label it, we name it based on those parallel faces, those bases that we have. Okay? And then we can see what happens is in order to construct this thing, I basically connect these bases. So as I connect these bases, what I form are these lateral faces. So I connect the bases, and I connect them using these rectangles. Those rectangles are the lateral faces of this thing because they're the pieces, they're the polygons that connect those bases. Okay, and so just kind of as I kind of trace this thing, showing you that, hey, the two sides that are the same, those are the parallel congruent faces, those must be the bases. And then as I connect those with shapes, the shapes that I'm drawing are the rectangles, those are the lateral faces of this thing. Okay, so this one, once again, is a pentagonal prism. The lateral faces are those rectangles, all right? If I look at the next one, the two sides that are the same, so the ones that must be the bases, must be the parallel congruent faces, are those triangles on each end. And so when I look at this particular example, these triangles must be the bases of this thing. So one triangle here and the other triangle here. And so we label this as a triangular prism. And the lateral faces on this thing are once again rectangles. As I draw the polygons that I need to connect those bases, I end up with rectangles. Those are my lateral faces. So like this guy over here, this is one of the lateral faces because it connects the two bases. This piece over here, that's one of the lateral faces because it connects the two bases. This piece down here is a lateral face because it connects the two bases, okay? So the bases are basically the pieces that are the same, those parallel congruent pieces that are across from each other. That's what we label, what we use to name or label this thing. And then those pieces that connect them are those lateral faces. The altitude of a prism is a perpendicular segment that joins the bases. So when we measure the height of this thing, essentially, if I were kind of to imagine this thing being turned on its side and saying, okay, the base of this thing, all right, or the bottom of this thing, the two congruent parallel pieces, all right, if I were to kind of rotate this and put one on the bottom, I'm essentially just measuring the height to get from one to the other. Okay. And again, whenever we measure distance or height, we always measure it as a perpendicular line because we always want to measure the shortest distance between these two things. And so if I look at this particular example, notice I have this piece at the top. So here's one of my bases, and here's the congruent parallel piece to this thing. All right. If I were to measure the distance between those bases, I have to measure it at a perpendicular angle, at a perpendicular line. That's the altitude. And so right here, this is the altitude of this thing off to the side. And notice it's one of my edges. That makes this thing a right prism. Okay, when the edges, when the polygons, the lateral faces that connect these two things are perpendicular to the bases, we call it a right prism. All right, as opposed to an oblique prism, almost like the Leaning Tower of Pisa here, where it's kind of leaned off to the side. We can still measure the distance between these sides. So once again, these are my bases. Those are my parallel congruent pieces. I can still measure the distance, but again, I want to measure the most direct distance, so I have to come off of that polyhedron, off of that prism a little bit and measure it. So that's an oblique prism, okay? But again, the height is always measured from the bases on this thing. So when I'm looking for the height of a prism, I'm always measuring the distance between the bases, all right? Regardless of the orientation of those bases, okay? You could have bases that are, like in this previous example right here, these bases are not written as like the top and the bottom, but the height of this thing would still be this distance, okay? So this would be the height of this prism, okay? Even though it's not turned the way we would expect it to be turned in terms of measuring that as the height, that is the height. That's the altitude, essentially, of this prism, okay? So you might have to imagine rotating this thing, changing the orientation of it a little bit, okay? The lateral area is the sum of the areas of the lateral faces. So basically, if I find the area of each polygon and add them together of the lateral faces, we call that the lateral area. All right. And then the second piece of this thing is the surface area. The surface area is basically the sum of all the areas of the faces. Okay. And when we talk about surface area of a polyhedron or a prism or anything like that, we're essentially just talking about the area needed to kind of coat the outside of this thing. All right. We would use surface area in something like a painting application. All right. I want to paint a three-dimensional shape. I need to know how much paint is required to cover the outside of this thing. What we're talking about is the surface area, okay? And so we kind of break surface area down into pieces. We break it into the lateral area, and then, of course, the area of the bases is the only thing that's missing then, okay? And so when you think about surface area, really it's the lateral area plus the area of the bases, okay? And so keep that in mind. That's kind of the way we'll approach this thing as in terms of finding the surface area. We'll find the lateral area, we'll find the area of the bases, we'll add everything together to get the total surface area. For example, if I look at this guy, I want to find the lateral area and the surface area. And so once again, as I look at this thing, the two sides that are the same would be this bottom piece down here and this top piece up here. Okay, those are the pieces I'm going to say. Now, here's the thing. Because this is a box and, these rectangular prisms are kind of unique in that really I could make any one of these sides the bases. Like I could say this guy and this guy are the base because those are also parallel and they're also congruent. And so I could think of those as the parallel congruent faces and think of those as the bases. All right, so keep that in mind. The rectangular prisms are special in that way. But this one, for simplicity purposes and because it's easier to think about, I'm just going to think about the top and the bottom as the basis for this one, okay? So I have a rectangular prism. If I want to talk about the lateral area, well, that's the area of all of these kind of side pieces. So if I look at each of these individually, like if I look at this side, and I could come off to the side here and draw a picture of that and say, okay, that side is a rectangle that's 2 feet, well, by 5 feet. I could label that and say, okay, I can find the area of just that piece. Well, that's 10 square feet. Let me write it on the inside of this thing. Okay? And so that's how we kind of start approaching the lateral area. I would then have to look at the next one and say, oh, how about this guy? This is part of my lateral faces. So let's find the area of that piece. And so I have a larger rectangle here for that front piece. And it's a 4 feet by 5 foot piece. And so once again, the area of that piece is 20 square feet, okay? And then I kind of keep working my way around. If I look at this piece over here, the thing I should recognize, I shouldn't have to draw this again and say, okay, that's a 2 feet by 5 feet. Just say, hey, it's the same as this guy, so I have another one of those. So when we're talking about lateral area, we just say, hey, I have 2 of this one, so times 2, okay? The same thing for the next one. If I look at the back piece of this thing, well, that was the same as the front of this guy. So I'm just going to say, hey, times 2 for this one. I'm not going to work each of these out individually if I don't have to. okay? And so when I look at this thing, in terms of the lateral area, I have two pieces that are 10 square feet. I have two pieces that are 20 square feet. And so what I really have here is I have a total of 60 square feet for my lateral area, okay? So it's just a matter of identifying the lateral faces and saying, hey, what's the area of each lateral face? What do I get when I add all those lateral faces together? Okay? And if it helps, come off to the side over here and just label each piece as you get them. This was 10 square feet. The front side of this thing up front was 20 square feet. This side over here was 10 square feet. And then the back of this thing was 20 square feet. Okay? And so if it helps to kind of visualize it and see it that way, and now say, okay, let's add all these together, that's fine. Okay? Then the surface area, all I need now is I need the area of the bases. And once again, just like with my lateral area, I had some pieces that were the same. Well, the bases are always going to be the same. Okay? And so if I look at this top piece, the top piece on this thing is a 2 foot by 4 foot piece. Well, the bottom of this thing is going to be the same, okay? It's going to be a 2 foot by 4 foot piece. So the top of this thing has an area of 8 square feet. The bottom has an area of 8 square feet. And so when I think about the area of the bases, I get an additional 16 square feet here. And so the surface area is just everything added together, so that's 76 square feet. Okay, and really for most of these, there's not a magic formula for these sometimes. We just have to kind of look at each case individually and say, okay, the area of the lateral face is this, so what are the area of the rest of these lateral faces? Okay. If I look at this one, once again, the two pieces that are the same this time are going to be these triangles. So this piece and this piece, so this triangle up here and this triangle back here, those are going to be my my bases of this thing, because they're the faces that are the same and are parallel to one another. Okay, so those are my bases. Everything else are the lateral sides. And so what I have to do is I have to look at these lateral sides individually. I have to say, hey, this lateral side right here, okay, that's a rectangle, and it's actually, if I kind of draw this, it's actually a rectangle that's, maybe I should, well, let's see if we can do it without drawing it here. But this rectangle is 3 by 6 centimeters. Okay, and so if I talk about the area of that rectangle, it's going to be an 18 square centimeters. Okay, so 18 centimeters squared. Same thing with the next one. If I look at like maybe this piece down here, once again, that is a rectangle, and that is a 4 by 6 rectangle. And so this bottom piece is going to have an area of 24 square centimeters, or centimeters squared. And then the last piece is kind of this piece, this big diagonal piece that's kind of at the top of this thing. And so as I kind of trace that thing, this top piece, well, that has dimensions of 6 on one side, but then I don't know what the dimension is on this other side. I'm missing this dimension. Well, I can find it by looking at this right triangle that's over here. Okay, so I actually have to do my Pythagorean theorem, 3 squared plus 4 squared equals c squared. If you take that off to the side, you do your Pythagorean theorem, you're going to find that this edge right here, the one I have labeled in red, it's actually 5 centimeters, okay? Which means, if I kind of clean this up a little bit, when I look at that top piece, even if I kind of draw it off to the side here, that top piece of this thing is 6 centimeters on this side, and it was 5 centimeters on this side. So the total for this one is 30 square centimeters, okay? So again, I have to find those pieces individually. Now the lateral area, well, the lateral area is what I get when I add all those lateral pieces together. So the area of all those lateral pieces looks like I have, if I can find all my measurements here, a 24, an 18, and a 30. Okay, so that's going to give me 72 square centimeters squared. All right. And now from here, if I want to find the surface area, all I need to do is find the area of the bases. And again, we're always going to end up doing that, finding the area of bases. Okay, so area of the bases. if I look at the one base, once again, it's a triangle over here. And we've made the assumption that it's a right triangle. Okay, that's we'll assume that's a safe assumption on this one. And so for this one, the area of one of these triangles, so the area of like this front triangle right here, well, that's 1/2 the base times the height. So 1/2 the base times the height. And so the area of this thing is going to be 6 square centimeters, or centimeters squared. And I have 2 of those, so the area of the bases is actually 12 square centimeters. And so now the surface area, when I add all this together, is going to be 84 square centimeters. Okay. The last thing we're going to look at here is cylinders. And really, a cylinder is kind of like a special prism. Okay, so a cylinder is a solid that has 2 congruent parallel bases that are circles. And when you look at that, that's really the same as the definition of as a prism. The prism was a polyhedron, so a solid, a 3-dimensional figure that had 2 congruent parallel bases. The only difference here is that the 2 congruent parallel bases are circles, okay? So it's kind of like a circular prism. Now, it's not technically considered a prism because it's not technically a polyhedron, because that side that connects, the thing that connects the 2 circles, is not a polygon, okay? It's kind of this curved piece. And really, we'll talk about that curved piece in terms of a polygon, but we have to visualize almost cutting it open and kind of unrolling it, all right? And so that's why this isn't technically a prism. It's basically like a prism where the bases are circles, okay? It acts the same way as a prism with the bases as circles, but we have to give it a special name because of the side that's connecting the circles. That thing that's connecting the circles is not a polygon, so this isn't technically a polyhedron, okay? And so when we look at something like this guy, we want to find the lateral area and surface area of this thing, okay? So the lateral area is the thing that's kind of tough with these, all right? Really, when you look at it, the bases are circles, and we can find the area of a circle. It's pi r squared, okay? So finding the area of the bases is simple. Finding the lateral area is tough because I have to do some visualization here. And if I were to kind of visualize, if I kind of took this this top off and I took this bottom off, if I removed those circles and just kind of had this kind of hollow, kind of rounded piece that makes the sides, imagine taking a pair of scissors and kind of cutting this right down the side. Okay, so now what's happened here is as I cut that thing, let's imagine it this way. Okay, so imagine this thing is kind of cut open. And let's say kind of springs apart here. Oops, sorry, I erased a little bit too much there. Oh. I'm going to draw it just a little bit smaller. So imagine kind of this cylinder has been cut open. So now like you notice those pieces are coming apart. And now imagine kind of unrolling this thing. So what I have here is I have this piece that was wrapped around to connect the circles, but I've cut it open to make it kind of look like this guy. All right. Now let's take that. It's almost like a piece of paper that was rolled up and taped together. Well, I've untaped it. I've cut it open. Now let's unroll the piece of paper. And so if I kind of unroll this thing, all right, what I end up with here is I end up with a flat edge here. When I unroll it, I'll end up with a flat edge here, and a flat edge here. And so really what I get is a rectangle when I kind of cut this thing open and unroll it. And so the lateral area really is a rectangle when we think about it as kind of visualizing this thing being cut open and rolled out. But the question is, what are the dimensions of that? And so if I kind of go back to the cylinder, here I had a height of 10 meters. Well, here I'll still have a height of 10 meters, which means after I roll this thing, I'll still have a height right here of 10 meters, okay? But now I have to think about this edge. And this guy right here is the tough one, okay? The length of that edge is essentially represented by this guy right here, okay? It's what I had before I unrolled this thing, which is really this entire circle before I cut the thing open and unrolled it. And so when you think about that edge, this distance around here, it's really the distance around that circle that represented the top of my cylinder. And so really this edge is the circumference of the circle when I think about the dimensions of this thing, okay? And the circumference of this circle is going to be 8 pi meters, okay? Remember the circumference of the circle is 2 pi r, so 2 pi r, the circumference of that circle is 8 pi meters. And so as I cut this thing open, the distance of this kind of top piece right here, all right, this distance around this guy is still 8 pi meters. And then when I kind of completely unfold this thing, that's still this same distance right here of 8 pi meters. And so when you look at this guy, here's the lateral area. The lateral area, I'm going to leave it in terms of pi for a moment, but the lateral area is just the area of that rectangle. Well, that rectangle is base times height. That's 80 pi meters squared, okay? So 80 pi square meters, that's my lateral area. And yeah, I could round that off to a decimal if I needed to. I'm going to leave it the way it is for right now because, again, when I find my surface area, I'm going to add more to this. I want to wait till the end to round it off if I'm going to round it, okay? And so now I need to include the area of the bases. And so once again, the area of the bases, if I kind of looked at maybe the top circle here or the bottom circle, well, the top circle here, the area is pi r squared, so 16 pi, okay? Once again, I have 2 of those, so the area of the bases total is 32 pi. And again, that's square meters. Well, now I can find the surface area. The surface area is what I get when I add these together. So if I add them all up in terms of pi, what I end up with here is 112 pi square meters. And that's literally my answer if I'm asked to leave it in terms of pi, okay? If I'm asked to kind of round this thing off as a decimal, now it's appropriate to do that. Again, I didn't want to do that until I at least had my surface area in exact terms, but now I could plug this into the calculator. And once again, use the pi button on the calculator to give yourself a little bit more accuracy. 251.33 square meters. And then the surface area. And once again, when I plug the surface area in again, I don't use that rounded off value. I go to the 112 pi in order to calculate this thing. So I get a 351.86. That's why it's important not to round off too early. Okay, follow the directions, leave things in terms of pi, and if it does ask you to round off, leave things in terms of pi until the end. If you're rounding things off, you should still be plugging this guy into the calculator to get the rounded off answer, and then this guy into the calculator to get the rounded off answer, okay? Don't use rounded off answers to get more rounded off answers when you can avoid it, okay? One more quick note here. You might also see as you kind of investigate and look at surface area of cylinders, there is a surface area formula for cylinders, and it's this. It's 2 pi r squared plus 2 pi RH. And I actually don't have that memorized. I just created that on the fly as I looked at my work. Because when you look at this right here, this guy is that lateral area broken down in terms of rectangle. When I cut this thing open and flatten it out, it's always going to be a rectangle that has the dimensions of the height of the cylinder, and the length of that rectangle is always going to be the circumference of the circle of that cylinder. And that's kind of what this depicts when we look at this thing. Here's circumference, 2 pi r, times the height. And that's the dimensions of that rectangle that we're going to get, okay? Likewise, the first piece of this formula, well, it's just the area of the circle, the area of one of those bases, and then, of course, times 2 because there's 2 of those bases, okay? And so, again, you can always approach this in the generic terms of a prism of, hey, find the area of the bases, find the lateral area, and add them together for surface area. Or you could use this formula if you feel like committing it to memory, okay? Really, just remember that anytime you want to find the lateral area of this thing, this is a piece that you probably want to remember, is that it's always, when you cut it open and flatten it out, it's always going to be a rectangle with dimensions of the height and circumference of the circle. Okay, and that's how we find that lateral area every time. Okay.